Alright, so the goal here is to estimate each square root to one decimal place, and that means we're estimating to what? Well, decimal values, right? One decimal place would be, for example, if I had 3.3. Here, the one decimal place they're referring to is this. This is the one decimal place. This is the tenths place. So here, a lot of the time, especially when you're learning to organize these square roots, you're always, I think, going to have to at least go this far, where you find to one decimal place value what these square roots are. And that means you're rounding to the nearest tenth. Start with the square root of 11. Well, what's that between, right? That's what you're first trying to find. Find the whole numbers it's between. It's greater than 3, because 3 squared is less than 11. And it's less than 4, since 4 squared is 16. So the square root of 11 lives between these two numbers, 3 and 4. Now 3 squared equals 9, and 9 is closer to 11 than 16. So that means the square root of 11 is also closer to 3, right? So here, what we want to do is try decimals that are closer to 3 than 4. And what can we do to find that? Well, I would try something less than 3.5. So what you can do is test numbers like, let's say 34 or 3.4 and square that. Let's try 3.4. So here we do the long multiplication. 4 times 4 is 16, carry the 1. 4 times 3 is 12, plus 1 is 13. Add a place value. And then 3 times 4 is 12, carry the 1. 3 times 3 is 9, carry the 1 is 10. We add these two up. Here is 6, 3 plus 2 is 5, 1 plus 0 is 1, and 1 on its own is just 1. Now, this is divided by 100, right? Because you can think about it by adding the digits before the decimals. Or think of it as 34 times 34, which is 1,156, right here. But it's 100 times smaller because you're really just doing 3.4 times 3.4. All that work tells you that 3.4 squared, and this is going to be the the really valuable information you need here, is 11.56. It's greater than 11. So now when we go back to where 11 is, we can rethink it a little bit. It is less than 4, but it's also less than 3.4 and above 3. So now what do we want to test next? Well, I see that 3.4 squared is really close to 11, so I feel confident trying 3.3 times itself. I think it's going to be above that. Let's see if I'm right. 3 times 3 is 9, and again, 3 times 3 is 9. Place value, and then again, 3 times 3 is 9, and 3 times 3 is another 9. We add these up. 9 plus 0 is 9. 9 plus 9 is 18. 9 plus 1 is 10. So 1,089, but it's really 100 times smaller, since 3.3 is 10 times smaller than 33, and this 3.3 is 10 times smaller than 33. So it's 10.89. That tells you that 3.3 squared is 10.89. Okay, well, that's less than 11. So when we go back to where the square root of 11 lives, it's above 3.3. So here, which one is it closer to? Well, I notice that 10.89 is closer to 11 than 11.56. It's only 0.11 away, right? 11 minus 10.89 equals 0.11. I just picture in my head 1100 minus 1089. Those are 11 away, but here we have it on a smaller scale, so I think it was 0.11, right? I just kind of think of it in that perspective. But you can do the long subtraction. So it's closest to 3.3, not 3.4, and that's to one place value, which, oh, that's kind of interesting. That's actually the decimal I chose as an example in the beginning. So here, 11, square root of 11 is closest to 3.3. And we have 2 more of these to go, so hang in there. So the square root of 11 is closest to 3.3. Clear this off. Next, we want to do the same thing with 30. But we can do a little bit faster now, right? So 5 squared is less than the square root of 5 is less than the square root of 30, because 5 squared is less than 30. And it's less than 6, because 6 squared is 36. It's above 30. So which one's it closer to? Well, 5 squared is 25. That's 5 away from 30. And 6 squared is 36. That's 6 away from 30. So I think it's closer to 5. So just like before, we pick a decimal that's closer to 5 than 6. I'll choose 5.4. And we square it. Multiply 4 times 4, that's 16. 4 times 5 is 20, plus 1, 21. Carry our place value. 5 times 4, again, that's 20. Carry the 2. 5 times 5 is 25, plus 2 is 27. We add these up. 6 plus 0 is 6, 1 plus 0 is 1, 2 plus 7 is 9, and 2 plus nothing is 2. This is really 100 times smaller. It's 29.16. So that's interesting. So what does that tell us? Well, that tells me that 5.4 squared, right, equals 29.16. So the square root of 30 is above 5.4. So we go back to this and we can readjust. It's above 5.4, and I'm going to test 5.5 next. Right? In fact, in many of these cases, the decimals you want to hop up 1/10 from 5.4 to 5.5. Multiply these two. 5 times 5 is 25, carry the 2. And again, the same thing, 5 times 5 is 25, and carry the 2. We get 27. Carry the 0, 5 times 5 is 25. 5 times 5 is 25 again, and then 27. Add these up. 5 plus 0 is 5, 5 plus 7 is 12, 7 plus 2 is 9, plus 1 is 10, carry the 1, 2 plus 1 is 3. So it's 30.25. So it tells us that 5.5 squared equals 30.25. That's above 30, right? So when we go back to the inequality we've written, we can say it's less than 5.5. It's between these two. And again, which one's it closer to? Well, is 30 closer to 30.25 or 29.16? It's closer to 30.25. It's only 0.25 away. So here, that means what? Well, I would use 5.5 as the square root of 30. And last but not least, the square root of 172. So here, with your perfect squares, you should know up to 16 squared. That's a good list to have down. Here, I know that 13 squared, right, equals 169. And I know that 14 squared, it kind of reverses those 6 and 9 digits to get 196. So the square root of 172 is between these two, right? It's greater than 13, but less than 14. And it's really close to 13. You can see that 172 is only 3 away from 169. So I'm going to try a decimal that's closer to 13. Let's try 13.1, and let's square that. 13.1 times 13.1. So here, right, this is, I think, a pretty tedious multiplication, stack multiplication, so you're free to use a calculator here, but I can do it really quick with you. 1 times 1 is 1. 1 times 3 is 3, and 1 times 1 is still 1. Place value. 3 times 1 is 3, 3 times 3 is 9, and 3 times 1 is 3. Again, more place value. 1 times 1 is 1, 1 times 3 is 3, and 1 times 1 is another 1. Now I want to add these up. We add up the 1's here. 3 plus 3 is 6, 9 plus 2 is 11, 3 plus 3 is 6, plus 1 is 7, and then 1 more, and then we carry that place value. Really close, right? So 13.1 squared equals 171.61. Now, here, 13.1 squared, that means that the square root of 172 is above 13.1, right? It's above 171.61. So that also means the square root is above 13.1. Now, the next one I would test is 1/10 higher. Let's try 13.2 squared. And probably don't have enough room. Let me just clear this off here. Okay. Sorry about that. All right, so 13.2 times itself. Last multiplication step. 2 times 2 is 4, 2 times 3 is 6, 2 times 1 is 2. Place value here, 3 times 2 is 6, 3 times 3 is 9, and 3 times 1 is 3. Last one. 1 times 2 is 2, 1 times 3 is 3, and 1 times the last one is 1. Add them all up. 4, 6 plus 6 is 12, carry the 1. 9 plus 5 is 14, carry the 1. 3 plus 3 plus 1 is 7, and then 1. So here we get 174.24. And that means that the square root of 172 is below 13.2, right? Which one's closer? Is 174.24 or 171.61 closer to 172? Well, 171.61 is only 0.39 away. Whereas this one right here is 2.24 away. You can verify that. But here, this just tells us that it's a lot closer to 13.1. It's a much better approximation. Now, as you work more with these, and the calculators get more and more tedious, you definitely want to use a calculator to support your reasoning. But the idea is that you're finding the boundaries for these square roots. All right, hope that helps.